Hello students, welcome you all. In my today's lecture, I will discuss the comparison between SN1, SN2, E1 and E2 reactions. And we will also see some of the problems based on substitution reaction and elimination reaction. In some of the problem, you will see only substitution product will be formed. In some of the problems, only elimination product would be formed. And there are few problems where both substitution as well as the elimination products are formed. So I have already discussed in detail the substitution reaction and elimination reaction in my previous lecture, and before coming to this lecture you should go through that lecture. Now, so how can we compare this? So there are various factors that affect the substitution reaction and elimination reaction, and based on that factor we can compare the product of formation in the reactions. Now, so suppose we have this four type of reaction. Okay, SN2 reaction, SN1 reaction, E2 reaction and E1 reaction. Okay. So based on substrate, that is usually this alkyl halide. So what type of alkyl halide gives this SN2, SN1, E2, E1 reaction? So I have already discussed this SN2 reaction, the reactivity order for this alkyl halide. So this is primary alkyl halide, or we may say this, suppose if we have alkyl group and then primary, then secondary. Whereas tertiary alkyl halide doesn't give the SN2 reaction. And we know that in SN2 reaction, the transition, this is a single step reaction where transition state is formed, and this SN1 reaction is a two-step reaction where carbocation is formed as an intermediate. So here in SN1 reaction, tertiary alkyl halide rate of reactivity order, tertiary alkyl halide is the faster one than secondary. Okay. Now E2 reaction, so it is not given by the this primary alkyl halide. Now for E2, that is elimination reaction, the rate of reactivity order for this alkyl halide. So if you will see, then tertiary alkyl halide, then secondary, and then primary. So why? Because in elimination reaction alkenes are formed, and either we take E1 reaction or E2 reaction. Both this tertiary alkyl halide, rate of reactivity of tertiary alkyl halide is higher in comparison to the this primary alkyl halide. So why? Because in tertiary alkyl halide alkenes are formed, and this tertiary alkyl halide, it gives the this most substituted alkene in comparison to the secondary and either E1 or E2. Okay, so tertiary gives the most substituted alkene. So this is the reason. Now, if we compare based on either nucleophile or base, so suppose this nucleophile or base. Now, substitution reaction, they are given by the nucleophiles, and the elimination reaction, they are given by the base. And we also know that some of the species, they act as a nucleophile and as well as the base. So we will see that one. Now nucleophile, this SN2 reaction, it is given by the strong nucleophile, whereas SN1 reaction, it may be given by the weak nucleophile, and in presence of some solvent, this SN1 reaction can take place. Whereas this E2 reaction, they occur in presence of strong base. Okay, so strong base, it deprotonates the proton. Now this E1 reaction, it may take place in presence of weak base. Okay, already we have discussed this in detail. Now come to the solvent, type of solvent. Now this SN2 reaction, it the rate of reaction is faster in polar aprotic solvent. In all this reaction, polar solvents are needed, whereas in SN2 reaction, polar aprotic solvent favors the reaction. In SN1 reaction, the polar protic solvent favors the reaction, because in SN1 reaction carbocation is formed and carbocation is stabilized by the polar protic solvent, for example this water or methanol, like this. In E2 reaction, this is favored in presence of polar aprotic solvent, similar to that of SN2 reaction, and E1 reaction, this is favored in presence of polar protic solvent, like that of SN1 reaction. Now, if you see the leaving group, then no doubt all should have the good leaving group. Okay, leaving group should be good for the better reaction. And this SN2 reaction, no doubt we should have good leaving group. SN1 reaction, it should have good leaving group. E2 reaction, good leaving group, but here in E2 reaction, the leaving group that should be anti to the hydrogen which is protonated. So good leaving group anti to the H atom removed. Okay. And in E1 reaction, no doubt it should also have the good leaving group, but the leaving group may be either anti or syn to the hydrogen atom. So leaving group syn or anti to the H atom removed. Okay. So we should follow this chart to do the problems based on this reaction. Now, so if we will see then about this nucleophile and base. So what I have told you, this SN2 reaction. This SN2 reaction, this is favored in presence of SN2, or SN1 reaction is favored in presence of a nucleophile, whereas E1, E2 reaction is favored in presence of base. Now this nucleophile, what some of the conditions that I told you, the nucleophilicity, that depends upon what are the factors on which the nucleophilicity depends. So nucleophilicity, it depends upon the charge density. It depends upon charge density. So higher is the charge density, better will be the nucleophile, and this charge density is inversely proportional to the electronegativity. If higher is the electronegativity, charge density, that would be lesser will be the charge density. So this charge density, that we can say this is inversely proportional to the electronegativity. Whereas the base, the basicity of any species, that depends upon the negative charge. The basicity is directly proportional to the stability of negative charge. Okay, or stability of we can say the conjugate base which is formed. Okay, so it basicity depends upon the stability of conjugate base, or stability of negative charge, we can say stability of negative charge over the species, or we may say stability of lone pair or lone pair. Okay, so we know that if the base is weaker, then it's the conjugate base. If it is weaker, then it's the acid that would be the stronger. So these are some of the factors that I told you. The nucleophilicity and basicity depends. But there are some of the species which may act as a nucleophile as well as the base. So let us see some of the species suppose if we have, there are few species which may act as a weak base and a weak nucleophile also. Weak base and weak nucleophile. For example, if you will take this water. So water acts as a weak base. Okay, water acts as a weak base and it also acts as a weak nucleophile. Whereas this in the same way alcohol also acts as a weak base as well as a weak nucleophile. And now, so strong, suppose I take a strong base and strong nucleophile. Now hydroxide ion, suppose this NaOH. So this acts as a strong base, and in the same way alkoxide ion, it acts as a strong base also. So this strong base, that gives, no doubt, that gives the E2 reaction, and strong nucleophile, what I have told you, that gives the SN2 reaction also. So if you will see here, then if any species which acts as a strong base, means this will either this species or this species, then it can give the it can give E2 reaction as well as the SN2 reaction. So it will give SN2 as well as E2 reaction. Now what about this weak base and weak nucleophile? So weak base, if we have weak base, then it can give a even reaction, or weak nucleophile, it can give the this SN1 reaction. So if we have water or this alcohol, then in presence of water or alcohol, the reaction that will give the either SN1 product, or we may say that E1 product. And overall, that also depends upon the type of substrate. We will see it also depends upon the type of substrate, whether both it will give both reaction or it will give a single reaction. Now, so next, suppose if we have a strong nucleophile and weak base, if weak base and strong nucleophile. So strong nucleophile and weak base. So for example, if you will see, for example, cyanide ion, okay, and this azide ion, iodide, bromide, fluoride ion. Okay, so they act as a strong nucleophile and weak base. And on this some of the, for example, if we have amine and this H minus H2S trialkyl phosphorus. So these species, they act as a weak base as well as a strong nucleophile. So why weak base? Because it's acid. This is suppose a conjugate base of the acid. So what would be the acid of this conjugate base? The HCN, the HCN that acts as a strong acid. In the same way, this HI, which is the acid of this conjugate base, so it acts as a strong acid. So this strong acid, and in the same way, if we have this HCl, HBr, they are the strong acid. So these species act as a weak base as well as a weak nucleophile, a strong nucleophile. So in presence of these species, what reaction can take place? So if we have a weak base, then even reaction, and if we have a strong nucleophile, then SN2 reaction. So SN2 reaction or this even reaction that may occur in presence of these species. So there are few species which are very strong bulky base, strong bulky base. Okay, strong bulky base. So this strong bulky base, for example, this potassium tertiary butoxide. Okay, potassium tertiary butoxide, or LDA, that is lithium diisopropyl amide. Lithium diisopropyl amide. So this is lithium diisopropyl amide. So this act as a, this is LDA, act as a strong bulky base. Okay, so strong bulky base that can usually it gives the E2 reaction. It doesn't give the SN2 reaction, because, and even it doesn't give the SN1 or E1 reaction, because a strong bulky base could not react with the tertiary alkyl halide, because this is a bulky one, tertiary already being one bulky one. That's why it doesn't give the SN2 reaction, and even this it doesn't give the bases. Since this is base, so base gives the elimination reaction. So this strong bulky base, it gives the E2 reaction. Okay, similarly the DBU is another one. DBU. Okay, this is diazo bicyclo compound, 1,5-diazo bicyclo compound. So for example, okay, so these are some of the species which may act as a weak base, weak nucleophiles. Few species, as you have seen, it acts as a strong base, strong nucleophile, like this. Some of the problems based on these factors. And now suppose if we have one of the substrate, this one, and is in presence of, suppose if we have sodium methoxide. Now, so what should be the product? So for this, either SN1, SN2, E1, E2 product may be there. So suppose this is SN1, SN2, E1 and E2. Let's check for it. Now, since this is a tertiary alkyl halide, so tertiary alkyl halide, if the substrate is tertiary alkyl halide, then it may give this SN1 reaction, because only the primary alkyl halide gives the SN2 reaction. So either SN1. So we can cut for SN2. It doesn't give the SN2 reaction. And what about E1, E2? Yes, it may give E1 or E2 reaction. So three type of product based on this substrate. Three type of product, either SN1 product, E1 product and E2 product. Now we should check for this species, whether this is a strong nucleophile or a weak nucleophile, a strong base or weak base. So now the sodium methoxide is a strong base. So if it is a strong base, then no doubt which cancels out? E1 cancels out, because the weak base, E1 reaction is given by the weak base, so this cancels out. And it is also strong nucleophile. This is a strong nucleophile as well as a strong base. So SN1 or E1 product is possible. So SN1 or E1 product is possible. So what product we can write? We may write the product. Suppose SN1 product is a substitution product. So in place of this bromide, we should write the substitution product here. This would come. And if you want to write the E2 product, then in E2 product, the beta H that is removed. So one of the H is over here, another H is over here, H is also over here. But this H, if this H removes, then you will get the more substituted alkene. So the product that you will get, so this is the product that you will get. This is tri-substituted product will be obtained if we remove this hydrogen atom. Okay, like this. Now suppose in a same substrate, suppose what I change, I have changed only in place of sodium methoxide. Suppose I take water, or we may take alcohol. Now in presence of this, what would be the product? So again check for SN1, SN2, E1 and E2. Now again, this is a first we will see for the type of substrate. Now this substrate is a tertiary one, that's why it will give SN, it will not give SN2, and tertiary is given by tertiary is obtained in SN1, E2 and E1. Now you should check for this type of either nucleophile or the base. So this H2O and this alcohol, it acts as a weak nucleophile and weak base. So it acts as a weak nucleophile, weak base. So the weak base doesn't give the E2 reaction. Only strong base gives the E2 reaction. That's why this E2, this cancels out. So two type of product, either SN1 product or E1 product can be obtained. So as per the this SN1 product, what should we may write? We may write this one. Okay, so suppose if we have this, then OH or OH that will be obtained, or OR that we may write here. Okay, now so plus another product that is obtained, E1 product. So this is our E1 product. Okay, so this product is formed via E1 reaction, and this product is formed via SN1 reaction. Here this product is formed via E2 reaction. This is formed via SN1 reaction. Okay, so these products are. Now suppose if we have a next problem where the substrate that I am taking is same substrate, but if we have, suppose if we have potassium tertiary butoxide. So in presence of potassium tertiary butoxide, so this is tertiary alkyl halide. Tertiary alkyl halide, it may give because this is a strong bulky base. So what I have told you, if you see strong bulky base, it only gives the E2 reaction. So in presence of strong base, elimination reaction that will take place, and only here E2 reaction can occur. So, and that's why the E2 product that would be obtained, only E2 product that would be obtained. So this should be the product over here. Now next one, suppose if we have a primary alkyl halide, now in primary alkyl halide, what this product that can be obtained over here? Okay, what is the product over? In suppose if we have sodium methoxide. Okay, so this is primary one, and various products that can be obtained, either SN1, we should check for SN1, SN2, E1, E2. Now since as it is a primary alkyl halide, so it is a primary alkyl halide, then we should cancel this SN1 product, because SN1 product is obtained by the tertiary or the secondary one. So this one SN2, and it may give E1 as well as E2. So here three possibilities are there. Now we should check for the species, whether this is what kind of base or nucleophile it is. So it is a strong base. It acts as a strong base. No doubt we will get the E2 reaction, but it is not a weak base, because E1 reaction is given by the weak base only. And it is also a strong nucleophile. So strong nucleophile SN2, strong base E2. Okay, so SN2 as well as E2 product is obtained over here. Now if you will see the product, then this SN2 product, this will be substituted by this methoxide ion. E2 product, beta H, that would be removed. If you remove beta H here, you will only see if this H is removed over here. So you will see that this product is our E2 product. This product is E2 product, but it is a mono-substituted product. It is, and the alkene which is formed over here is a less stable alkene. So that's why no doubt this would be the minor product and this would be the major product. One is minor, this is major. Okay, so here it is SN2 product is, and two type of product, SN2 and E2 product. Now if I change, if I take the same substrate is same. Okay, substrate is primary one, and here I write suppose alcohol in presence of alcohol. What will be the reaction over here? What should be the reaction? Or if we have suppose water, suppose if we have water, then what should be the reaction over here? Okay, so here what you will get either, now again check for SN1, SN2, E1, E2. Since it is a primary alkyl halide, that's why primary alkyl halide is only SN1 is possible, SN2 is not possible. So cancel for SN2, it is primary one, and either E1 and E2 both. So SN1, E1, E2 as per the substrate. Now we should check for this, either this is strong nucleophile or weak nucleophile, strong base, weak base. So this is weak base and weak nucleophile. So weak nucleophile, it is given by the weak. If we have weak nucleophile, then SN1 reaction is possible. Okay, and it is a weak base, that's why it is a E1 reaction is possible, but E2 is not possible because E2 is given by the strong base. So product that you may write, it would be this one, and another, as per E1 reaction, the product would be this one. So this is the product which is formed via SN1 product, and this product is formed via, this is E1, by E1. Okay, so SN1 and E1 that is formed. Now, so if you see here, then out of this two, this would be the minor, again this would be the minor product. Okay, now if we have suppose this one, and in presence of bulky base, suppose if we have LDA, and this is a primary alkyl halide. So the base, strong base, only gives the elimination reaction. So we will only get the here, it is a primary substrate. So primary substrate, that is either E1 or E2. But what I have told you, the strong bulky base is only gives this E2 product. So that's why the product formed, that would be, this should be the product, and this is formed via E2 reaction. So this is about when we have the, here I have taken the substrate that is taken is either tertiary alkyl halide or primary alkyl halide is taken. Now suppose I take the secondary alkyl halide. Suppose I take secondary alkyl halide. Now this one in presence of, okay, so here what should be the product? So first of all you will check for SN1, either SN2, E1 or E2. Now because it is a secondary one, now secondary, that may give SN1, SN2, E2, E1, all. So all are possible here as per this substrate, all are possible. But now we should check for this is species, whether what kind of base or nucleophile it is. So this is a strong base. Strong base, it means what cancels out? This cancels out. It is a strong nucleophile. Strong nucleophile, it means SN1 cancels out. So either SN2 or E2 product that would be obtained, and so product that you will write SN2, it is substituted by this one, and then E2, this would be, so this should be the product. So this is our E2 product, and here you are getting the SN2 product. Okay, now so if we have, suppose, now again check. So again this is a secondary one, so either all possibility as per this one, either SN1, SN2, E1 and E2. Now as this water acts as a solvent and it acts as a weak acid, a weak base and a strong weak nucleophile. That's why either SN1 or even reaction is possible. So what cancels out? This cancels out. Weak base, so that's why this cancels out. So SN1 or even product is formed. So product that you will obtain is by SN1 reaction and by E1 reaction. Okay, so in this way we may decide based on substrate molecule and based on either kind of nucleophile or base, we may decide for the product.